Hey, what's going on, everybody? I'm just here to do a demonstration video for DMVPN, phase 1, 2, and 3. So this, just to give you a brief explanation of what DMVPN is, it's I wouldn't say it's it's a cost-effective solution if you want to be able to provide a full mesh, partial mesh, or hub and spoke network deployment without having to deal with the dedicated circuits that come with having to purchase say an ATM service or a frame relay service. With DMVPN, you can throw it on top of whatever transport medium you really want to, as long as it supports IP. That's the main requirement for it, is that it just supports IP or IPv6. But essentially what DMVPN is made of is GRE, multi-point GRE, or GRE, point-to-point GRE tunnels, and NHRP, next top resolution protocol. And the way they work in conjunction, the multi-point GRE tunnel is typically built on your hub devices. And then depending on the deployment that you're doing, in regards to the phases, either you'll have a point-to-point GRE tunnel built on your spokes for your phase 1, and then for phases 2 and 3, you would actually have your multi-point GRE tunnels on the spokes. And essentially what NHRP does is it acts like a replacement for ARP, where instead of resolving your layer 2 address, what it does is it resolves your MBMA address to your tunnel IP, to the destination tunnel IP. And the way that works is, depending on which phase, either the hub gets you that update or the other spoke gets you the update. Like I said, depending on the phase that you're in. Now, you just want to go over the phases. So essentially a brief overview of the different DMVPN phases. So phase 1 is essentially your standard hub and spoke phase. So what initially happens during every phase of DMVPN is once you got your hub configured and you configure your spokes, you configure your spokes with something called the next hop server, which is actually your hub of the network. And the initial first piece of communication that ends up happening is that each spoke would send a registration message to the hub. And what that registration does is it pretty much builds a NHRP table for the hub. So we'll just do NHRP. So in this case, so when 5 originally gets into the network, router 1 will start building up his database, and he'll see that 5's IP address. So the tunnel IP would be 155.0.100.5 with the mapping MBMA mapping address of 10.100.0.14. And same thing goes with router 3. He's going to send that initial registration, and he's going to get up to router 13, router 3. And then we go to 10.0.1.10. So now this is what ends up happening at first with the, let me go ahead and see if I can get that a little larger for you guys. There we go. Alright, so that's the initial registration process. So getting into the different phases. So phase 1, after this whole initial registration happens and the hub has the spokes registered to itself, what's going to happen is, say that router 1 needs to send traffic to router 3. And phase 1, the way phase 1 is designed to work is that, like I said, you're going to have your point-to-point tunnels set up on the actual spokes themselves. And what's going to happen is all the traffic, all the data plane traffic that needs to get to router 3 is going to actually have to traverse over router 1 to go back down the pipe to get to router 3. And as you could probably imagine, that doesn't scale well, especially when you're having, a couple thousand spokes. The amount of configuration that's going to go on the spokes, and especially if you want to run redundant tunnels or redundant next hop servers, can be a bit painful. And it utilizes the spokes bandwidth, because every piece of traffic that needs to happen from spoke to spoke communication has to traverse the hub, so that's very inefficient. And that's when phase 2 comes into play. Now, the thing with phase 2 is that the spokes now have multi-point GRE tunnels, And they actually are able to communicate and build dynamic spoke-to-spoke tunnels. And the way this happens in phase 2 is actually through router 1. So initially what ends up happening is, say that router 5 wants to reach a network behind router 3. We'll just say this loopback address right here, right? So what will happen at first is the first data packet will actually go through. If the first registration packet the first data packet will trigger a registration, an NHRP registration, just like an ARP request. If you don't know the IP address in your actual forwarding table, what do you do first? You send the registration message. So what ends up happening is that, see, once you initiate that ping and you don't actually have that dynamic mapping for router 3, because what's actually going on in the background, and we'll get when we get into the configuration. So one of the drawbacks of DMVPN Phase 2 is that you can't do summarization, and the reason why is because the NHRP resolution request, it is dependent on the actual next hop of your routing update. And what I mean is that here on this router, you would actually say that we're running, and in this case we're running EIGRP. So for phase 2, what we're going to do is we actually disable next hop self and split horizon. Because what will happen is router 3 will pass his update to router 1. Router 1 is going to take that EIGRP update packet. He's not going to modify the next hop to make it himself, and he's just going to forward that over to router 5. So when you look at router 5's routing table, he'll actually have a specific route going to router 3. He'll have a specific route going to router 3 with router 3's next hop address. So what ends up happening is that once you send that initial packet, you trigger the resolution request, right? So you send the resolution request up to the next hop server. The next hop server then queries his database. Once he realizes that, oh, I have a mapping for router 3, he's then going to send that update. He's going to send that resolution reply back to router 5. Router 5 now updates his actual NHRP table, and now from that point on, data traffic will not traverse router 1. It's going to go directly to router 3. Now you see that's a little bit more efficient, but the fact is you can't do summarization because it's derived. It needs to have that next hop for when it does the when it goes to do its recursive route lookup and actually tries to figure out where that packet needs to be forwarded. It will need to do that initial communication with router 1 so it can NHRP can update its database. Now, phase 3 operates a little different. Well, and the configuration is not that much different. You still going to have the multi-point GRE tunnels for the phase 3 approach. The only difference is that instead of router 1 replying to your resolution request, what's going to happen is he's going to do a redirect message to router 5, right? Router 5 would then forward that registration request directly to router 3, and then router 3 is going to respond, and at that point, that dynamic tunnel will be created for that piece of communication. But it operates a little bit differently. So with phase 2, well, let me go back to phase 2 because I know that I said that you can't do summarization, but especially if you're studying for the IE lab, I actually ran this by Narvik. And if you're not familiar with Narvik, he actually wrote the CCIE, the new CCIE V5 book, and I kind of just came across a possible solution because one of the things with this lab is that, everybody thinks it's a best practice, it's all reading what Cisco designed. It's not about that at all with this test. It's all about understanding the technology and knowing when to implement something and knowing when not to. And knowing your options that are available when you're tasked with a specific task. So with phase 2, essentially what you can do if you want to provide some kind of a default route going out to your spokes, with EIGRP for instance, it has a feature called leak map. So you can send out that default route your summary address going out to router 5. Now remember, the biggest driving point with phase 2 was the fact that it needed to have that specific route in a routing table for NHRP to trigger the resolution of router 1 so that it could build that dynamic tunnel. So if you leak the actual if you leak the routes that are needed for spoke-to-spoke communication, and you leave the next hop self still disabled, what will happen is for that specific route or that specific destination, he'll actually still try to forward using the next hop of router 3. The resolution request will still get sent to router 1. Router 1 will still send it back to router 5 and create that dynamic mapping. And I actually tried this in a lab. That's definitely, if you guys want to play with something and you want to try to see if something works, I would definitely give that a shot. Just get used to doing stuff like that. Think outside the box whenever you're configuring your stuff. All right, so with phase 3. Now, like I said, with phase 3, the way phase 3 works is it enables you to just go ahead and add a default route, and you don't have to do that workaround like I explained. Because what ends up happening for those specific routes that get added to the routing table, it's actually NHRP that creates it for you. So that way you actually have a Ceph entry. So when you do your recursive route lookup, it'll forward it directly to router 3, and it will never ever touch router 1 as far as the data plane goes. Try it. You get some kind of control traffic that still hits router 1, but it's very minimal, and that's only the initial resolution request that gets to router 1. And the way it works is that router 5 needs to send a network traffic over to router 3. The initial resolution request will go to router 1. Router 1's gonna notice that router 3 already has a dynamic mapping, and it'll see that it has that redirect command configured. So what it'll do, it'll redirect that resolution over to router 5 with the updated destination information, so that it can actually send its resolution request directly to router 3. And at that point, when router 3 replies with that resolution reply, that tunnel was built. Now, with NHRP, like I said, you'll see in the router 5 routing table, for that specific destination, you'll actually have a Ceph entry for that destination, as well as a Ceph entry for your tunnel IP, the next hop tunnel IP. So like I said, it makes it efficient for recursive routing. And with NHRP controlling the routing updates, you don't have to get into a complex configuration like I explained with phase 2, where you're running a weak map, and say that you have more subnets that need to be added. Yeah, you can do a prefix or a range, but if you don't have your network set up in a good contiguous manner, then it's not going to really work out well. So that's just a high-level overview of phase 1, 2, and 3. Now, people get DMVPN mixed up with IPSec because of the VPN portion of the name. Now, just know that DMVPN, what makes the main driving points is GRE and NHRP. Now, if you want to secure the traffic, you can throw IPSec on top of it. And what the IPSec does is just encrypts the payload. Depending on how you actually apply the IPSec, you can do a crypto map on the physical interface, or you can do tunnel protection on the actual DMVPN tunnel. But essentially, that is your it adds an extra layer of security on top of your GRE encapsulated packet. So just understand that IPSec is just an extension to DMVPN. I'm not going to say an extension. It's a feature that you can enable that runs on top of DMVPN. It doesn't really run in parallel. So just keep that in mind before, once you get into that, just understand that you can actually, in this configuration that you'll see, I'm not going to configure IPSec. Just understand that it's possible. I might have another video where I'll do it, but in this one I'm not going to. And in the next, the actual CLI video, I'm not going to. Now, one of the things I would recommend is if you want to get some good information, a good understanding of what DMVPN is, I would recommend getting over to the Cisco documentation and reading through they have a few design docs. They have a good configuration guide that pretty much tells you exactly what you need to know for configuring DMVPN. And where you would actually get to that software is if you go to configuration guide, get to that software, where you would get to that, let's see. Alright, come on now. My computer is acting up, so you guys gotta bear with me. It's because I'm running this, I'm running the Snagit at the same time, so it's acting up. It's acting a little crazy right now. So you want to go to configuration guides. Once you get to the configuration guides pane, you want to go to secure services and VPN. Now, it's actually under secure connectivity configuration guides, and then from there you'll have the DMVPN. you would click the DMVPN. And another one I would recommend you guys read through is if you go to the IP addressing section. Where is it at? Where is it at? Where, there it is. So you want to go to the IP addressing section, and I would recommend reading the NHRP document as well, just so you have a better grasp and a better understanding on what NHRP is, how it actually operates, you know, and the caveats and, you know, design restriction. Pretty much everything you need to know will be in these documents for the most part. And then, you know, go play. Now, before we go into the actual configuration in the next video, I do want to go over the topology first, just to show you guys exactly what I'm doing and what the overlay is what the underlay and what the overlay is gonna be for the DMVPN network. So in this particular topology, we're just gonna focus on router 1, 3, and 5. I was gonna do it with dual NHS, but in this particular, just for sake of time, when we get into the configuration, router 5, 1, and 3 will be a part of the same DMVPN network, and we're gonna go through and configure each phases. Now, the underlying network is what I wanted to do is demonstrate how a customer can actually run this on top of, say, their MPLS VPN v4 topology. So, you know, you would buy your long distance MPLS service, whatever it is, whatever the service provider, and you would get your peerings, right? Now, the multi-protocol, the MPBGP, if you're not familiar with it, it allows customers to be able to peer with a different routing protocol, and then the service provider would then transport that using BGP sessions between their provider edge equipment, so that the routes for the customer's equipment will make it over. And in this case, just to show you guys some diversity on the service provider side that I'm emulating, I actually have each spoke in the hub coming in at different type of routing protocols for the underlying network, right? So router 1 is peered with eBGP to the ISP, and he's exchanging routes that way. He's exchanging the routes for the WAN connectivity for the NBMA access. Router 3 is using OSPF, and then router 5 is actually using RIP. And one of the things that I'll show you guys, we'll get into the command line just so you get a high level understanding on what I'm doing here. So this is the GNS3 topology. I know it's nothing elaborate. I got everything separated using the .1Q trunks, and got sub-interfaces configured on the router, so that's how I'm doing my logical separation. But essentially, you see that I have the router named INET MPLS. That's simulating my WAN, my underlying WAN connectivity. If we go back to the document here, so we have my MPLS cloud and internet cloud. Essentially, on the router, I have two VRFs created. One VRF called MPLS, one VRF called INET, and respectively, those networks stay within those inside that routing domain. So if I do a show IP VRF, you can see what I was explaining there. So I got the INET at MPLS. And then if I do a show IP route VRF MPLS, you can see that I got some routes. I got my connected routes going on there, right? Now, looking at the from the point of view of the actual hub and spoke devices, we can just verify, you know, we can see connectivity. So what we want to make sure before we get into this is I'm going to just have you just walk through and verify with you guys how we can make sure that the NBMA connectivity is working. So from router 1's point of view, that's the main important part of the network. We need to make sure connectivity is definitely possible. I mean, from an NBMA network, you're going to need to make sure you got full connectivity on the underlying. So if from router 1's point of view, we do a show IP route, and we'll do a show IP route BGP. Now, you see that, and you know what, I just realized we may not be learning the route that I need for show IP route for 13. Yeah, we're not. We're learning that route right now. Alright, so okay, there it goes. That's 12. Huh, let's see why we're not learning that route. Because essentially, you see how I got all the routes here. I should be learning this route here via router. Alright, but I don't think I did a redistribute RIP into BGP. Let's see. Let's see if I redistributed RIP into the MPLS VRF. And like I said, this is just making sure the underlying routing is working. So let's look and make sure that I did that. And you can see I did it. I didn't redistribute RIP into it. So let me go in there and let me redistribute RIP into the BGP process so we can move on with this example. Router BGP. Now mind you, this is the ISP router, so this is what the ISP would be doing for you. If you had to exchange your connected routes, they can do the distribute connected, or they can just do a redistribute through the other protocol. Whichever they want to do, it's really up to them, depending on design, of course. IPv4, VRF, MPLS, right? And then we want to redistribute RIP. So we go back to router 1. We should have that network now. Show IP route BGP. Perfect. So now we have the 12 network in there. All right. So what we're going to do is, so based off of the map, we're going to ping .100.0.6, which .5 is the router, is the ISP. .6 is my spoke. So in this case, for the add IP address, that's going to be the connection. Also, we're not going to worry about router 2. So 8 and 12 is the most important ones. Okay, so let's make sure we can ping 8 and 13, or really 10. So 9 is the ISP, 10 is the underlying network. You can see we got connectivity. And then in this case, 13 is the router, 14 is my spoke. And we can verify the path that it's taking, 10.100.0.10. As you can see, it's going through the ISP, right, to get to those hops. 13, 14. And you see we're going through the ISP for that to work. So once we get into the, so just showing you the underlying network, this is exactly, you know, how we got the underlying connectivity. And then the next video, we're going to go into actually configuring the tunnels for the DMVPN access. And we'll go through the different phases just to show you guys how it operates and, you know, what to look at once you get the initial configuration done. All right, thanks again. Later.